Hi dear students, good morning to all. This is Bhausef Sonone, Assistant Professor, Department of Chemistry, Arts, Commerce and Science College, Java District, Palghar. Dear friends, right now from the first lecture on this solution, we discussed about the various types of the solution. Dear friends, in the last part of the video, we tried to discuss about the partially miscible liquid pairs, and we came to that with the stirring of the solubility or the miscibility of both the conjugate solution with one another goes on increasing, and it is possible to have either upper critical solution temperature or the lower critical solution or both. So we in the last lecture we discussed about the various types of the systems which shows upper critical solution temperature, lower critical solution temperature, as well as upper and the lower critical solution temperature with the help of different examples. Dear friends, today in this part of the video, we are going to talk about the immiscibility of liquid pairs and their distribution. Here, the two liquids are said to be immiscible if they are completely insoluble with one another, hence the system will consist of the two phases. Though it is usually referred to as a mixture, examples are different. Oil and water, that is oil and water, or the kerosene and hot water. There are different examples like these which are completely immiscible, and there will be a small degree of mature solubility. Here, since the immiscible liquid do not interact with each other, they will evaporate completely independent of each other, and each liquid will contribute its own characteristic equilibrium, vapor pressure, independent of the pressure of the other liquid, and hence the total pressure exerted by the mixture is the sum of the equilibrium vapor pressure. So this is the that is total pressure will be the equilibrium the pressure of both the component A and B. So this is the thing that we discussed, and the relative proportions of the two liquids in the mixture can be calculated with the help of this equation. If Na and Np, these are the number of moles of the component A and B in the vapor phase at the boiling point, then this Na upon Np is equal to P0A into P0 into A divided by P0 into B. So this is, if the weights are given, then definite number of moles can be converted into weight divided by molecular weight. So this is the simple, it is not important. Steam distillation. Here the phenomenon explained above forms a basis for the steam distillation, where the steam is added to an organic mixture to lower the boiling point of the mixture. Water from immiscible mixture with most organic substances, and this mixture will boil at a temperature below that either of water or the other liquid. Here the example. Here the example of water and the phenomenon can be taken to understand the principle behind steam distillation. In the presence of water, phenylamine boils well below its normal boiling point, and normal distillation of these liquids would need quite high temperature, and many of these big molecules will be broken up by heating at high temperature. But distilling then in the pressure of water avoids this by keeping the temperature low, and can be done by steam distillation. And this is the assembly for steam distillation general use. So this is the mixture. So definitely steam is passed in this mixture. Definitely the liquid will be converted to vapor, and that vapor will be passed to this, and it will be condensed outside here. Okay, so this is the way by which definitely we will be able to separate the one liquid from the other one. So here application to extract some, the actually nurse distribution law is very important. Whenever the two immiscible nor the non-miscible solvents are there and they are solute dissolved in both of them, so it is related to the distribution of solute in two non-miscible means immiscible solvents. However, the solvent dissolves in both. If the solute is soluble in both immiscible liquid pairs, then definitely it follows the nurse distribution law. So according to the Now distribution law. If X distribute between two non-miscible solvents A and B at a constant temperature and X is in the same molecular form in both of these solvents, then the ratio of the concentration of X in two solvent is constant. That is, concentration of X in solvent A divided by concentration of X in solvent B means C1 upon C2 is equal to K. So this is the equation according to the Nernst distribution law, and the constant K is called partition coefficient and is denoted by the letter Kd. So here this is the one example. Iodine, a violet crystalline solid, when added to a mixture of two immiscible liquids, water and carbon tetrachloride, then it distributes in both of them. The value of K in this case is 85 at room temperature to 98 Kelvin, and the applications of this Nernst distribution law is the principle of distribution law is quite helpful in metallurgical operations. A popular example is desilverization of lead. But the limitation of this Nernst distribution law is that the solute which is to be distributed should not interact or should not react with any of the solvent. It's very important. And the solute should not undergo any change in its molecular state in the solvent. It means that it should neither undergo dissociation nor association. So this is the important thing, and definitely for this the solvent extraction method can be also used. The process of separating a substance from its aqueous solution by shaking it with suitable and immiscible solvent is called as solvent extraction. So means whenever you want to separate a component from aqueous phase, aqueous solution with the help of organic solvent or another solvent, immiscible solvent, then it is called solvent extraction. This is a separation technique and useful when the product is volatile or thermally unstable. Solvent extraction is an equilibrium process based upon the distribution law or partition law, and separating finally is used for this technique. And the solvent extractions are again two types: the solid and liquid extraction. In liquid extraction. Solid extraction is used in this process. The substance is removed from the solid by dissolving them in the solvent, and definitely it's subjected to the solvent extraction apparatus is used in this purpose. For the extraction of the liquid extraction, it is usually applied to separate the organic solute from the aqueous solution, and in this method aqueous solution containing organic solute is shaken with the help of ether in a separating furnace. So this is very important. The organic solute will move from water layer to the ether layer, and the inorganic impurities remain in the aqueous layer. And a separating foil is used for this purpose, and separator is shaken vigorously for some time until equilibrium is established, and the separator is fixed in a stand. This is the process actually. Later on, the whatever organic layer that consists of ether, as it is the volatile, so definitely this will go off and only the product will remain here. So it is preferable to do many extractions with small fractions of the solvent as compared with the single extraction using a large volume of the solvent, because the quantity of extracted product depends upon the distribution constant. So it's very important to use this technique whenever the solute is soluble in the aqueous, but whenever you use this technique, it can be separate from the aqueous phase or the aqueous layer. So dear friends, in this way we try to complete this all the content of this solution topic of the solution unit. We try to cover various types of the solution based upon their nature, based upon their characteristics, based upon their miscibility or the solubility with one another. We try to discuss all the aspects of solution in this semester. So I have all the concept of this topic regarding the solution should be clear to you all. In case any doubt, you can ask, you can put the message. So here based upon the same, some MCQ can be asked to you, some problems can be asked to you based upon this topic, entitled as solution. So based upon the same we will have some assignment as well as some test that we will conduct. But here now this is the completion of the topic entitled as solution. Thank you very much.